Hello, everyone. Welcome to this webinar that we are doing with TransformUK. We are looking specifically today at green ops and sort of green digital transformation. So how can you make your IT estate more sustainable? How can you embed some of the great work going on in the world of green software, in green ops, and actually really trying to sort of make your coding, make your IT estate as energy efficient as possible. We're really pleased to be working with TransformUK on this. We have a really good program of activity that we'll be sharing afterwards at techUK that we'd love to get you guys involved with, not just from a green software point of view, but also from what companies can do to improve the green digital skills. So the digital skills agenda, which is so important, can be sort of applied to sort of green and digital. So yeah, welcome to this techUK and Transform webinar. I should have introduced myself. I'm Craig Marston, the Associate Director of Sustainability at techUK, where we look at climate change, net zero, recycling, human rights, ESG disclosures, and everything in between. And Transform, one of our members. We've got an excellent panel here for you. And I'm now going to hand over to Claire to actually kick off the webinar. We'll be doing a Q&A at the end, so please use the Q&A box in Zoom to put your questions, and I'll be sort of fielding them after the presentation. So over to Claire, and ready to get started.
Cool. Thanks so much, Craig. So I'm going to kick off with a few introductions. So I'll start with myself. My name is Claire Robinson. I am Director of Sustainable Business Consulting at Transform. So the best way to think about Transform is that we're a data and tech consultancy with serious service design chops. So we build a lot of the digital services for public sector, but also very complex private sector businesses. So our purpose is to solve knotty problems where there isn't a blueprint. So the next person I would like to introduce is Anne. So we have Anne Curry on the panel. Anne is CEO of Strategically Green and author of certainly the most accessible book I've ever read on software development. She has written Building Green Software, which was actually released just earlier this year, actually. And it covers how to build, host, and operate code in a way that's better for the planet and also cheaper for your business. And Anne is a co-chair of the GSF community as well. I'm going to introduce Jerry next. So Jerry McGovern. He is inventor of the top tasks methodology. So I'm sure if you are into UX at all, user experience, then I'm pretty sure you'll have heard of that methodology. But he's also a prolific podcaster and author of the recent super hard-hitting book, Worldwide Waste. Now, this book really lands the point that digital is physical in a very real way. And it kind of extrapolates on a lot of the hidden consequences, the hidden environmental consequences of digital consumption. Finally, I'm going to introduce Naveen. Naveen Balani is the co-chair of the Standards Working Group and the Impact Engine Framework at Green Software Foundation. Now, he's been engaged with the SCI metric, which is the software carbon intensity metric that we'll be talking about later today, right from the very beginning, up to its accreditation as an ISO standard, again, earlier this year. So that just happened, I believe, in March. So he is also an award-winning author, including a book called Green Software Essentials. So without further ado, I'm going to get into a bit of the context of today's session. So I guess we've all by now heard the headlines. If tech was a country, it would be the third largest emitter now, just behind the US and China. Technology is responsible now for 4% of global emissions, which is actually larger than commercial aviation. And with the advent of generative AI, that's actually increasing in the short term. So we all know that there's a huge problem to address. We all know that there's regulation coming down the line. So mandated Scope 3 reporting is just around the corner. For the UK, it's already embedded within the EU. We're really kind of waking up to the reality of the footprint of our digital estates. And also that there may be loads of valuable ways within that to reduce our overall carbon footprint. So I can definitely feel the starting of a movement. Businesses are very much starting to understand this and then address this. So that's why we've created this webinar essentially. The first part is going to be very much focused on the metrics. So how can we measure our digital estate? And the second part about interventions, how can we actually improve that over time? So most businesses start with kind of getting under the skin of their own carbon footprint. I know I can speak for myself when definitely I can say that scope 3 can often feel like a quantum entanglement challenge. It's super complicated to decide what metrics to use, how to use them. I think at least now there is starting to be some consensus around particularly carbon metrics. But the whole purpose of being able to measure is so that we can improve. So hopefully after today's session, we'll have some quite practical advice on what organizations can actually do to reduce impact. So hopefully you'll leave today with some actions that you can implement in your organization. So that's the intro. I'm going to get started with measurement and start with you actually, Naveen. I'd like to understand, I guess, the journey at Green Software Foundation from the inception of the software carbon intensity metric and perhaps its journey all the way to becoming an ISO standard earlier this year. But I'd love to kind of understand practically how we as technologists can actually use that metric, and if you have any examples there.
Sure. Yeah, thank you, Claire, and very happy to be part of this webinar. So when we started the Green Software Foundation 3 years back, green software was a relatively new area. And one step we worked towards as a community was creating a standard to measure the carbon emission of any applications. And that's where the software carbon intensity was born. An initial version of SCI specification was piloted in 2022, which went through rigorous testing, and all member organizations applied SCI to various use cases to make it more actionable. And I'm happy to share that the SCI attained ISO standard this year, which will, in my view, significantly increase adoption and also reflect the combined efforts of all our member organizations. So think of SCI as an open source specification that is created for the tech community, and it's easy to implement SCI. So SCI is basically a score per unit of output. The score can be, for instance, carbon per user, carbon per transaction, or maybe carbon or AI prompt for a generative AI application. And a lower SCI score is better. And to calculate SCI, you first define the software boundary of your application. For instance, what do you want to measure? It can be a web application, cloud application, an AI inference application, open source package, or maybe a database applications. And once you define the boundary, you define the scale. Think of scale as how function unit or how your application scales. For instance, for a credit card company, it can be transactions per second. For a B2B, it can be B2B application, it can be number of users. Or for an AI application, it may be prompts per second. And once you have defined the scale, then you go about doing the measurement. And you calculate the SCI score for each of the applications using real world observations or lab-based measurements. And finally, you have the SCI number. So from an equation perspective, the SCI equation is quite simple. It's basically energy which is consumed by the hardware, which is running the software application, multiplied by the carbon intensity, which is basically the intensity of the electricity at during that time, plus the embodied emissions of the hardware, which is running the application, divided by the function unit. And what's unique about SCI is we have made the SCI actionable. So SCI score can be reduced by 3 key levers. So if you follow these practices, you will definitely have you can reduce the carbon impact of any application. So the first principle is energy efficiency. So basically developing energy efficient software that uses less electricity to perform the same function. The second is around hardware efficiency. Try to use less hardware, physical hardware for same amount of work. and also relying on energy efficient chipsets. Nowadays, a lot of cloud providers, vendors gives you a lot of energy efficient chipsets that can be utilized to lower your carbon emission and increase energy efficiency. And third important point is how basically making applications carbon aware. So think of carbon aware as determining the region where the renewable energy run, or during the day or time, right, when you have a clean energy. So doing workload shifting based on region and time, you can lower your carbon emissions. And as part of the foundation, we have developed many such public use cases, right from cloud applications to hardware optimizations on how can you measure the software carbon emission across the stack and lower your emissions.
Thank you so
Over
much.
to you, Clara.
So are you starting to see, I guess, consensus around the way businesses are actually using SCI?
Yeah, I think especially with the ISO standard, we're getting the ISO standard, right? I would say we will be getting a lot of consensus now because now SCI is an open standard which can be used for measuring any software applications, including an AI application also. So definitely, I would say with the ISO attaining SCI attaining ISO specification, as well as the tools that we are building as part of the foundation, like the Carbon Aware SDK and the Impact Engine framework. All these tools are easy for organizations to implement SCI score and report it.
Cool, thank you. So let's get further into the kind of practicalities, I think, of measurement. So maybe I'll turn to you here, Anne. How should we actually measure the impact of the software that we build in a really practical way? Are there any challenges? Are there any opportunities? Are there any examples here that you'd like to share?
Well, before we go into that, I'm actually going to go back to the SCI, and because actually Naveen and I had a very interesting discussion about this only last week, and I think it's worth saying because a lot of I do a lot of teaching, a lot of my community raised this as well, that the question of what's the SCI ultimately for? And I know that I was confused about this to start with. What is it? Is it for comparing one service with a different service, something completely different? But in fact, if you look at it, it really isn't that. It's more like a like for like. So it's so that you can. It's a bit like I used to work in retail, and we used to use like for like all the time. If you move to when you're comparing how much money you've made this year, you say, well, how much money did I make per square foot? Rather than, if I opened another store, I'd expect to make more money. So I need to have a look to see underlyingly, is my business getting more profitable? Because per square foot in any particular location, don't compare London with the Sahara Desert, that kind of thing. And the SCI is all about like for like, because it's very specific to a particular application. It's you choose how are you going to do all the measurements. You choose what your denominator is going to be. Is it going to be per user? Is it going to be per transaction? Is it going to be, which makes it almost impossible to do comparisons between different services. But it is very useful as a like for like comparison. So and it is very useful to have like for like. So you can say, oh, well, this year I'm better than last year. And of course, even with that, it's difficult. Same as in retail, you can't compare this Christmas with last year's February. You can't compare this sunny summer with last year's cold and wet and not very windy winter. Because it all matters that the energy the carbon intensity of the grid that you're running on matters, and that changes over time. So it's all these things they're great, but they can't just be used blindly. You need to pay a lot of attention to them. In the same way that I constantly say that where people should start, waste is, I'm thoroughly in agreement with Jerry that waste is the major issue here. That we need to be. That's the lowest hanging fruit. Get rid of your waste. and I quite often like to use folk to use cost as a rough proxy for, you know, have you got any waste in your systems? But again, none of this stuff can be used blindly, because you could be cutting your cost because someone gave you a great excellent deal on reserved instances in your cloud, and that doesn't save anything. That's just in fact that's likely in the long run to lead to greater waste. That where cost is decoupled from usage, then that's a place where waste can really build up. So yeah, I tend to encourage people to start with cutting waste and start with cutting their hosting bills, but make sure that their hosting bills reflects what they're doing and aren't, you know, a secret way of you of just accumulating a whole load of unused hardware and resources. Yeah.
Do you think there's also a hidden risk there, though, in using cost as a proxy? Because obviously that could really hide either better or worse environmental performance by the cloud providers, right?
Oh yeah, definitely. Because at the moment the cloud providers don't pass on. I live for the world of dynamic tariffs, time of use tariffs, where you pay for electricity, what it costs, which increasingly is how dirty it is. So you pay more if it's more dirty, and you pay less if it's clean. There are some countries Spain is doing some excellent work around dynamic tariffs. Some of the Scandinavian countries doing that as well. It would be lovely to see that start to be reflected in your cloud bills, for example. I mean, it is on-prem if you're in one of those regions, but I would love to see it be reflected more widely, because that's where you really get alignment between carbon awareness and cost. Without that, it's not quite so good. It's better than nothing, but it's nowhere near as good as it will be in the future. And of course, it will come. Dynamic tariffs are coming.
Thank you. So I'm going to turn to you finally on the measurement question, Jerry. Can you, I guess, articulate perhaps some of the broader planetary impacts? You know, is there a risk in focusing on either cost or carbon as a metric, as a single metric?
Yeah, thanks, Clara. I think single metrics are always dangerous, and Anne was talking there about cloud providers, and for many years they have had a pitch which said even though data was exploding, their energy efficiency was very strong, so they weren't using so much more electricity in relation to the explosion in data. Now that has all changed in the last 18 months or so, but for the previous 10 or 15 years, that was their big pitch. Now, how they achieved a lot of that was by using vastly greater quantities of water. So because they started shifting to cooling using water than using air conditioning. So they, in a sense, because they were saying, look at this metric, look at the carbon metric, they started pumping out fresh water, which is a global freshwater water crisis. So another area where they achieved efficiency was by constantly churning through server architecture. So if a new server architecture came out that had an incremental improvement, they would essentially dump the previous architecture, which might only be 18 months, 2 years, maybe 3 years old maximum. Now, when you consider that commercially at least 50% of the damage, and in a normal consumer environment, 80% occurs in the manufacturing. If you're constantly churning through your physical architecture and waving the flag, look, our carbon is improving, you're actually destroying through mining and through all sorts of other impacts. So while carbon it's wonderful, it's a foundational metric, and it's extremely important, I think any metric on its own is dangerous, because you start cheating. Like there's 9 foundations of life that scientists have discovered, and temperature is one of them. There's soil, there's oceans, there's chemical, etc. So there's many other factors, and I think one of the things we have avoided historically is calculating the true and total cost to the environment, and carbon is just one of those costs.
Yeah. So how would you kind of advocate organizations approaching this kind of like more holistic framework for metrics? What sort of metrics we'd like to start to see?
Well, you can do what? I mean, there's some rough figures on water. Like a laptop is probably somewhere between 150,000 and 200,000 litres of water to manufacture. A smartphone is 14,000 litres. We have some data now, finally, from the data centres about water consumption. So you can actually often track their increases in water consumption with reductions in other ways. So we can track water usage in the development of software, development of otherwise. We can track mining impact. Because there are some rough models that say a laptop creates 90 kg of mining waste. Sorry, a laptop creates 1.2 ton. A smartphone is about 90 kg. So there's models that are tracking back, because mining is actually where the most environmental damage goes. Many people would consider biodiversity to be more important than actual climate. And biodiversity is absolutely collapsing. And one of the key drivers of its collapse is mining. And not all mining happens for technology, but technology, and particularly green tech, is driving 4 to 6 times more mining to create machines than other more traditional type machines. So mining and water are two new metrics that I know we have to start somewhere, but let's not exclusively focus on carbon, because the data centers really cheated when the focus was only on carbon.
Yep.
Yeah, I agree. PUE is a very gameable score, and as time goes on, it's no longer it's not even the best thing anymore, because we've got better ways of generating electricity these days. That's it's now become in many ways vastly better to use aircon than water, and yet people focus on PUE as a score. It's very destructive.
Yeah, I can definitely agree that, just focusing on carbon, I think, the whole industry focusing on net zero is an issue, because you could actually achieve net zero, but actually be responsible for biodiversity collapse in totality. Okay, I want to shift a bit now to, I think we've had the discussion around the metrics that we can use. I'd really like to get to some super practical examples if we can. Opening up a discussion around what can technologists actually do on a very practical day-to-day level. Positive interventions, things that have provably worked to reduce carbon footprints. And this question is quite broad, so thinking about, it could be business strategy, could be research methodologies, could be design, development, hosting, optimization, really, really broad. Who would like to kick off on that one?
Well, I'm happy to kick off slightly, because I think we'd all be in, again, total agreement on this. Reducing waste. It's stuff where you're using a load of resources and you're not actually getting any benefit from it, and that's provably quite. I've spoken to so many people who've reduced maybe 50% and their knock-on benefits, 50% of their hosting bills, by just going through and paying attention, right sizing, because over provisioning is waste. Machines that are running and doing things you don't really need them to do anymore, that's just waste. I spoke to somebody from VMware last year. I think he was talking about how they moved, and moving, when you move data centers, is a really good time to do that. So, but you don't have to move data centers to do it. You can kind of like have a virtual data center move where you go, well, hang on a minute, could we achieve the same kind of levels of improvements that you'd get from moving data centers and really concentrating on throwing away or getting rid of all your systems that are not doing anything for you anymore? So a 50, we have the new Green Software Maturity Matrix at the Green Software Foundation, and our first step there is manually, don't do anything clever, just manually review all your systems and get rid of the machines that aren't doing anything for you anymore. Downsize things. Just don't do anything fancy, all manual, and you should be looking to reduce your hosting bills by 50% and your carbon emissions by 50%. And that's probably the biggest change you will ever make. And it's the easiest change. All the low-hanging fruit is right in front of you.
Thanks, Anne. Can I ask you the same question, Naveen?
Yeah. So I would think we need to embed sustainability as part of the overall solution, right? From design, development to deployment. Let me give you an example of AI in general, right? So both traditional AI and generative AI, as we all know, take massive amount of energy required for training large-scale models. For instance, there are stats which says that training a single AI model can emit as much carbon as 5 cars over the entire lifetime. And if you look at the AI systems specifically, right, they require significant computation resources, which not only consume large amount of energy, but also lead to increased electronic waste due to rapid iteration of necessary hardware. So if you look at from an AI perspective, it becomes essential to what we call apply and adapt green AI practices during various stages, let's say for AI development. For instance, if you're doing data preparation, it's important to use data more efficiently.
Oh,
I've just lost Naveen. Has everyone had the same thing?
yeah, yeah. Oh, he's back.
Oh,
If I can hear him. No.
Naveen, we can't hear you.
Can you hear me now?
Yes, perfect. Sorry, could you carry on? Thank you.
I'm not sure where. Okay. So let me start again. So what I'm talking about is AI having a significant carbon footprint, and it's crucial crucial to adapt practices like green AI, as we refer, which is all about embedding energy efficiency and reducing carbon emissions throughout your AI lifecycle process. For instance, if you're doing data preparation, you could look at filtering out redundant or irrelevant data so that your downstream processing can be more efficient. Let's say if you're doing a training phase, techniques like pruning, which removes unnecessary neural network weights, or things like quantization, which reduces the precision of numbers, can help you create models which are more lightweight and are more carbon efficient. Similarly, in the inference phase, you can use strategies like distillation, which makes your model more efficient and more performance. So you can deploy small scale models at various edge devices also. And then you can use new innovations like things like green prompting, where you interact with AI systems, generative AI system through prompts. So how can you ensure that the prompts you create are more precise and energy efficient? So this is just one example I gave for the AI lifecycle, but similarly, you can look at across, apply all these practices, right, for maybe a web application, backend application, right, and try to embed sustainability in whatever work you are doing.
Thank you, Naveen. So on to you, Jerry. I know we've had loads of conversations around the less hardware, the better, and you've done some incredible calculations in your book, which really, lands the impact of this. But would you take that any further?
Yeah, I think what Anne talked about there as well, cutting the crap. That's the simplest and easiest, and most of the organizations I've dealt with over the last 20 or 30 years, 90% of their data is waste. So finding that, getting rid of it, or archiving it properly is probably the single biggest achievement you're going to have within the environment. I think looking at reuse of, if you realize that most of the impact is in the hardware, then often, a lot of that is in the creation of using that hardware to create software. So if you don't have to create the software from scratch and can build from it, reusable modules, that's definitely going to have savings. And holding on to, see, there's these trade-offs between efficiency. I think efficiency is probably the most damaging metric in modern society. It has done so much damage, but holding on to devices longer, because where the impact is in the manufacturing. The longer you can stretch out the life, you might lose a bit in processing efficiency, but you've actually saved on mining and material use. So really looking after refurbishing, a lot of the stuff gets thrown out while it's still in really good working condition, really looking after machines, looking to have, I would say, you really need 20-year lifespans for laptops before they begin to become anywhere near sustainable, and we are a long distance away from that.
Yeah, I couldn't agree more. And we've been talking at Transform about kind of putting that power into people's hands to be able to choose, you know, and see the environmental impact of when they, you know, of when they update their hardware, you know, to give people the choice. You know, because I think there is a kind of hidden question here, which is about mindset, right? So it's about culture and about people being, you know, cognizant of the changes and the impacts of the decisions that they're making. So I guess maybe let's talk about culture for a sec. Let's talk about, you know, do we think this is kind of more of a, you know, metrics challenge, or is it more of a mindset challenge? You know, do we need to support the people in organizations to make better decisions?
Well, I'll say I think there needs to be a heck of a lot more awareness people really want to do something about this now. The world has changed in the past 5 years. We've gone from nobody really believing it. I mean, 5 years ago, I don't think people really believed in climate change. Now that is not the case. People believe, but they have no idea how to go about it. They have no idea what role tech plays, and they have no idea what role their business plays in it. And they don't know where to start. It's amazing how many people think. So Jerry mentioned the danger of efficiency in this conversation. It's usually, more often than not, when I start to talk about this, people will say, "Oh yeah, but we know we'd have to rewrite all our systems in Rust and, you know, to be code efficient, and then we'd go out of business doing that." And they're quite right that they would go out of business if they tried to rewrite their systems in Rust, but they are completely wrong when they think that that is either the first thing to do or the most important thing to do, or possibly anything to do at all. And I'm as guilty as anybody else, because 10 years ago, I thought it was that the benefit was everybody should rewrite everything in Rust, because it will make things much more efficient, but it's never going to land. It's not the way that the world is going. So yes, yeah, if awareness, and also awareness of what not to do first, which was the reason why we did the maturity matrix, the Green Software Foundation, was basically to say, don't start there. That is the last thing you do. And ideally, you'd get it off a platform. I mean, I'm not saying that no one should ever rewrite their code in Rust. There are plenty of people who should, but they are the people who are running really highly used, high scale software, not an average enterprise. They should just be looking at the easy stuff first. And that's kind of the awareness of the strategy. Do the stuff that you can do, and buy the stuff that you can't do off the shelf, and demand it off your suppliers. I would say is the key thing that we need folks to take away.
Mm-hmm. Can I ask you to speak to that as well, Jerry, about the kind of mindset shift that's required?
Yeah, I think most of it is culture. I mean, we have now a culture of waste, essentially, and planned obsolescence, etc. So really having a respect for the materials, that looking at your laptop and thinking there's 60 plus materials in this laptop, and thinking that, you know, in that chip required 400 chemicals. That's a lot of impact on the climate. To make one chip requires at least 400 chemicals. Now, chemicals are not good for water. They're not good for air. They're not good for anything. So we have this thing here that is very powerful, but has had a really, really significant cost. And as Nazim said, with AI is just blowing everything out of water. We're talking about 10, 20, 30 times more environmental impact with AI than with more standard systems. And so much of AI is just a scam, like as well. It's just a total scam and grift. You know, it's the great big lying machine. It means that it's the so-called fact machine that can't even get its facts right. So I think AI is a scam, actually, a giant scam. But it's whether it is or not, it has a massive environmental impact, and particularly in water, because the chips get so hot. The only way you can cool them is with water. So these things are having extraordinary impacts on fish, on birds, on animals, and we don't think so. We don't realize the physical impact. So get back in touch and thinking about the materials and the impacts of the materials that are in our digital devices, because digital very much is physical and has an exponentially increasing physical impact on our world.
I'm super interested in the ways that we can actually, I guess, start to like harness, you know, human culture and behavior to direct it in a more positive direction for environment. You know, do you think, and I might go to you, Naveen, on this question, if you've got any interesting examples here of, you know, being able to work with, I guess, the humans on the other side of the screens to be able to kind of create the shifts that we need to happen.
Yeah, I think it's a good question. So in my view, adapting green software, right, requires a significant culture shift within the organization, emphasizing sustainability alongside, let's say, traditional priorities like efficiency and security. And that transition demands it to be met across all levels, right, from executive to developers, integrating environmental considerations into their core values and operation. And this shift, I would say, not only reduces the environmental impact of technology, but also enhances company reputation and opens up new business opportunities also. For instance, just as security is now a standard part of any software, I say green software should be the norm and embedded right from the start. And particularly around artificial intelligence, right? Given or talked about AI having a significant environmental footprint, definitely I'm a believer that if you apply green AI practices, right, it from our perspective, from the tech community perspective at least, we can lower the emissions, lower the carbon emissions, and make energy more AI energy efficient applications, right, which can be used by millions of developers.
Absolutely. And I think you mentioned security there, but I think, you know, the security agenda is quite aligned to the sustainability agenda in most instances. Can I maybe reach out to you then, Anne, as a kind of final question on, I guess, yeah, the culture change that's needed. And I guess you work a lot with, you know, training organizations, many people. I wonder, you know, kind of, can you comment on, I guess, where we were versus where we are now and where you think we're going?
So it's interesting. Where we were, as I said, 5-10 years ago, where we were was most people were a bit dubious to even mention this because they didn't really believe in it, or they kind of thought it was true, but they were a bit embarrassed in case it wasn't true, and then nobody else thought it was true, and they'd kind of look like an idiot. So that has changed. So that's massively good. Now everybody believes in it, or most people believe in it. It is now the majority view that climate change is happening. We need to do something about it. And you look like a bit of an idiot if you don't believe in it and you don't want to do something about it. So that's good. But we are, as I mentioned before, we are now in the hair shirt phase, in which we think that we don't really want to do it because the only way to do it is to either rewrite all our systems in Rust and therefore everybody would go out of business, or turn off everything so there's nothing, so we'd all go back to living in the 17th century. Neither of those things are true either. We now need to get to the next stage where we're thinking, well, hang on a minute, there are enormous benefits, so many benefits to actually being able to run on renewable power, for example, because you know, when the sun's shining, we now have exponentially growing quantities of energy, and we need to be using that energy to do all the good things. So if waste is just waste, get rid of that, because it doesn't return you anything. But we could be using that energy to find better ways. I mean, energy is the ability to do anything. So we can solve so many of our problems if we just concentrate on the energy we have, not the energy that we had. So don't attempt to change the world in the middle of the night on a windless night in January. Attempt to change the world in the summer. We need to start thinking about and living by the world around us, and rather than what we just dug up from the earth. But yeah, I don't know what everybody else thinks.
Go ahead, guys.
No, agreed. Yeah, and but also to add a little bit onto it is that renewable energy is not renewable. It's just, I mean, the reason why solar panels are so cheap now is because China cuts down 14,000 football fields of forests in Myanmar every year just for the charcoal to do the silicon, and because they've got essentially Uyghur slaves making the solar panels. So these things are not free. They have impacts. 90% of solar panels are currently not recycled. I know the EU are bringing in some laws. So they are less damaging than oil or gas, but they're not zero. They don't have, dams have massive impacts on ecosystems, destroy rivers, etc., etc. So these things that we have painted as, they've a kind of a zero cost to the environment. They're not as costly as coal. They're not. So I think our core problem is not an energy production problem. It's an energy consumption problem. We're always looking for this new tech fix so that we can keep on consuming. We can't keep on consuming. We have to look at how we consume and reduce consumption. Otherwise, I don't think we'll survive another 50 years without a massive civilizational collapse. I don't think people really realize how bad things are. I don't think they have any sense of how bad things are and how quickly they're getting much, much, much worse.
But I think that's a reason for adopting that really broad approach to measurement that you were advocating earlier. It's actually starting to understand not just carbon, but water consumption, biodiversity change, and being able to measure that so that we can start to realize our actions and optimize against it.
Exactly.
So I'm going to ask for some audience questions now. I can see there've been a couple. But perhaps I'll hand to Craig at this point, because I'd love to kind of understand what questions you guys have. So do tap in the Q&A if you have anything else to ask the panel.
Yeah, thanks, guys. That was a really, really good discussion. Really wide-ranging, which is great. So the first one's from Ishmael. I think he's looking for sort of the panel's opinions on the sort of broader impact of AI and sustainability, which is obviously something that, how long is a piece of string really, depending on what you're doing. But obviously, he's going to mention the direct emissions from building and running, I suppose the infrastructure and the models. How do you actually then get some sort of rebate from making things more efficient and using AI to deliver sustainable solutions? And then kind of indirect damage from faster economic growth. So that kind of goes to the sort of, I guess, the classic rebound effect that, you can use AI to make, a factory more efficient. That might mean that you can actually become more energy efficient and more logistics. But if you're helping higher emitting sectors become more efficient too, you're in that classic rebound things. Yeah, what are kind of member opinions on that? They sort of broader, more holistic view of, AI in this.
I think there might be an actual calculation to be done here. I'm a massive fan of metrics, and I'd love to almost create a framework where we are able to measure not only the kind of positive impacts that we're making with AI. So, if we are, being able to, diagnose cancer more effectively, obviously that's got a huge social impact. But being able to balance that against the environmental, degradation which happens by the use of that model. And so being able to actually start to measure it, I think will enable us to have those conversations in a more informed way, because everything is essentially a trade-off between, humans, technology. So I think just having a more informed calculation around what net positivity actually means.
Does anyone else in the panel have a view?
Yeah, just
will have a good example for that.
Just one example. I don't know if I pronounce it right. NVIDIA chip. Somebody was telling me that when it's idling, it's consuming more energy than 3 standard chips. So it's a 3 standard server. So a NVIDIA server idling is actually consuming more than 3 standard servers in the process. So not even when it's working. And a lot of these things spend a lot of their time idling as well. So it's a massive jump in energy, and I really struggle. I mean, everyone comes up with it's going to solve. For the last 50 years, we've been hearing the next technology is going to solve cancer, and it didn't, but the core purpose of AI as well is advertising. I mean, the people who are building it are advertising companies, Google and Facebook, and they're building it to sell more ads. So we're driving over consumption. It's more energy intense, and its core purpose is to sell us more stuff we don't need. So it has a thumbs down environmentally on every side, except it's making a lot of people a lot of money.
So I think we do need to be incredibly nuanced on AI. It has some amazing possibilities, and everybody, as I say, as Jerry says, using curing cancer is the get out of jail free for everything, isn't it? But maybe it will. It's not. But it also has enormous environmental impacts. But at the same time, I don't think it's a genie that's going back in the bottle. So I think what we have to do is really, really put incredible. It is the first massive new industry that is being created at the time when everyone believes in climate change. So, and there's a load of discussion going on. So really, we should be seeing them addressing it. We should be seeing them saying, well, hang on a minute, how are we doing this? How are we addressing this? We should be constantly saying, well, yeah, do the AI. I'm not saying don't do AI, but do AI in a way that is aware of the world in which we live, and the fact that the energy transition is coming. What is your plan to not make sure that you are running NVIDIA chips that's in the middle of the night in January in a windless January? What's your plan here? How are you aligning what AI does with everything else that's going on in the world at the moment? It's amazing how people are getting the usual suspects are getting away. Getting out again, it's a bit like we'll cure cancer, and also we'll run it on fusion. Well, fusion is not on the table at the moment. How do you run it on what we've got? It's totally doable. I think there's loads of good potential in AI for being green, for at least being vastly more aligned with what we're doing than it is. Curing cancer is not a get out of jail free, and neither is fusion. It has to be, where are we now and what are we going to do? I would say with AI, great potential. Loads of stuff has great potential, but doesn't always necessarily deliver on it.
Yeah, I think techUK, we would agree with that, because obviously we've got very active AI programs, and we're kind of like, we did a really good webinar actually on sort of the best use cases. And I think if you look at what the World Economic Forum say, there's like probably 20% emissions reduction on offer as well from digital tech being used to kind of decarbonize heavy industries, whether that's in the power sector, transport, manufacturing, construction. That's probably more than most government policy would ever achieve. We're big sort of AI fans, but we're still trying to wrestle with that And it's a weird one as well, because obviously different locations will have different solutions and different problems. I mean, water cooling, it just isn't an issue in the UK. It's an issue in some places, but we use air cooling in the UK. But then obviously that's not solace to people whose reservoirs are being consumed in random deserts in America, who, you know, because the policy environment is one where you're being encouraged to build a data center in the desert. In the UK, you can barely get any data centers built at all, even on waste ground next to the motorway. There's a few more questions I'd like to field to you guys. I'm going to take, there's two actually that are very linked, so I'm going to come back to it in a bit, or three actually. But Jerry spoke about language, and calling design marginal efficiency sustainable. It could be argued as greenwashing. Sufficiency is really difficult. So how do we kind of address the language used around sustainability in tech to actually kind of move the dial and actually kind of get some of these solutions deployed?
Education, education, education. That people need to understand what it is that everything in tech, we need to get everybody aware of what's going on, what's the energy transition is about, what's happening, what's good looks like, and so that they can make judgments for themselves. When they hear something, you can go, because it's everything in technology is it depends. There's no right. It always depends. And the trouble is, in order to be able to make a decision about whether, trade-offs, you need to understand what it is you're trading off, what the value is. And so it's really awareness and education, I think, absolutely front and center.
And I think going back as well, the materials, begin to think about the materials that you're using. I think we've lost touch with our world. We don't think about what we eat, where it comes from. But even a lot of times when I tell people, that laptop is aluminium and plastics and cobalt and lithium, they say, what? Like they kind of think that they don't see the phone as something physical. Like, start thinking, and then how can I repair this? How can I buy something that is repairable? Because the longer you can keep your materials in life, are they recyclable? Are they reusable? But I think we need to start thinking about our materials. And then, as Anne said, the education, but education on materials. I think we really need more education on the materials that we use in the technological industry, which has kind of been invisible up until now.
I think there's some super interesting, AI intervention in materials science at the moment, though, in terms of being able to look at new polymers, look at new ways of actually creating much less damaging materials. And so that's a really interesting use case where, the potential benefit probably outweighs the detriment.
I mean, I do say that I'm not a total disbeliever in AI like Jerry. I think there is tons. I think it could be amazing. I just want it to be amazing and also clean.
And yeah, just to kind of talk through some of the stuff at techUK actually on materials, obviously, because this is a huge area for us. We've got some really interesting policy questions here in the UK. I think we've obviously taken a more hardline approach in Europe, but this whole tension between durability for devices and repairability. So if you're trying to meet the waterproofing standard, for example, you need, for portable electronics, whether it's a laptop or a phone, you need to make things really enclosed, really tight. So you've completely compromised on repairability, but then you're also trying to eliminate the main reason something needs to be repaired anyway, which is water damage, typically, especially if it's something people are, responsible for. And we've also tried to navigate this tension because we have a lot of device manufacturers in membership. You've got this huge tension as well, which is super interesting, around safety and reliability. On one hand, people are being told to make things more repairable, but the other hand, you've got another bit of government saying make your stuff really safe, because you're going to get a lot of people bricking and breaking their stuff, and potentially hurting themselves too. So yeah, I don't envy them. And the big solution is obviously get more recycled content, but there's only a limited amount out there that's actually any good. We had some great examples from members who are not able to get the quantity, especially of recycled plastics and polymers. You're not getting sufficient grade quality just because it's not available, and you're competing with, you know, everyone else in the world who wants the same quantities of like decent one. But so super interesting though, the material science.
I will actually a quick. I think the low hanging fruit here again is for software engineers. I mean, so my phone, I never drop my phone down the toilet, and that which is quite surprising because I'm the kind of person who would drop the phone down the toilet. But I always have to throw it away because it runs out of security patches, and that's not a hardware problem. There's no trade off there between safety and repairability or whatever. I'm throwing away a perfectly working device because it's run out of security patches. And that's a software problem. That should be much simpler to solve.
Yeah, they got the new ETSI standards and the new well, they call it the PSTI Act in the UK, which is based on a European one. Yeah, to try and basically address some of those issues. I've got a couple of questions here that are kind of related, so I sort of take them together. So one is mostly around kind of corporate culture and education. So going back to what you're sort of saying, and so how do we land the enormity of this issue to senior leaders? How do we kind of, you know, if we are to believe that civilization collapses 50 years away, that we'll be living in that 2074 will just be Mad Max essentially. But how do we kind of motivate people to change? And I think as well, I can't even talk today, but raising awareness of green software and sustainable IT principles outside the sort of core sustainability teams. So I think all these questions address kind of corporate culture, education, and building capacity in companies. How do you kind of address those issues?
Well, people can read our books, which are designed to be. Well, certainly mine is, and it sounds like Jerry's is as well. Naveen, yours sounds a little bit more techie, but we need to bridge the gap between sustainability teams who know all this stuff and understand it and believe it, and engineers who don't really understand it or believe it or kind of think that they're in any way involved. You've actually got to entertain people a little bit while you're doing that. It has to be the kind of thing where you go, oh, I'll go to a conference on that, and actually it'll be nice, it'll be fun, I'll learn some interesting new things, and I'll learn about the future, and I'll learn about all the positives that can come from being able to shift. People in the technology industry love problem solving, and this is a really interesting problem to solve. It's not all about misery. It is also about having something really inspiring to do that you can change the world with your code. You know, it's a really nice message. I think we need to be constantly emphasizing the fact that this is not all doom. You know, we don't believe that we're all doomed here. This is a solvable problem that we will enjoy solving. You can save the world as a software engineer.
I would absolutely agree with that in terms of the positivity of the message, because I think there's nothing more kind of motivational for the human psyche, I guess, than to understand that, you know, if you make actions, then they will have a positive effect. And actually the collectivity of that positive effect can actually have, you know, far-reaching implications. Yeah, so I think to just let people know that they can make a difference and how, and then show that collectivity. Yeah, I agree.
Yeah, I would like to add that if you look at green software, right, it's more of an optimization problem. And now with tools being available, right, it's easier for developers to integrate in their day-to-day jobs. And probably it's the first time where developer has a say, right, create software, better software, which has directly an energy impact, whatever work they do, right? I haven't seen, I mean, this is how our software community, right, can give it back. Create more energy efficient software, carbon aware software, right, and make and contribute our part towards a positive environment.
I think in general, constantly thinking about the total cost to the environment. You know, it's it's hard to begin when we're just getting started on carbon, but we have to go broader. We have to be asking, what's the total cost to the environment of this specific activity? So even beginning to ask that question, I think, would be a good start.
Thank you. So we're coming up to time. So I really appreciate everyone's time. Perhaps I can hand over to Claire to perhaps outline some of her sort of concluding thoughts, or before we wrap up.
Yeah, absolutely. No, I thought that was a super valuable session. Obviously, we started off on metrics, went through interventions into culture. Yeah, I just would like to give a massive thank you to all the members of the panel. You've been incredible. Yeah, what we're intending to do is just a wrap up post. So we'll give you all of the kind of links and docs and things that we've discussed today. Yeah, but if you've got any more kind of questions that are burning, or you want to have arrange separate sessions, we're more than happy to do that. But yeah, just a huge thank you to the panelists, and also a huge thank you to everyone for attending. Thanks so much.
Yeah, thanks everyone. Yeah, as Claire said, we will be following up, and we will be sort of sharing sort of materials afterwards. So yeah, thanks for TransformUK for putting this together and inviting such an excellent panel. And we'll wrap it up. But thank you very much, everyone.
Thank you.
Thank you.
Thank you.